Hi there and welcome once again to this Me versus Math tutorial, which today is focused on the sine rule and more specifically using the sine rule to find missing sides. If you've not yet viewed our first tutorial on labelling sides for the sine rule, then I must insist that you watch that first or you may struggle to follow what is going on. Assuming you have, let's get started. Okay, the formula that you're looking at here is what is known as the sine rule, and the first thing a lot of students notice is that it has two equal signs in it, which seems a little odd, but that's really nothing to worry about at all. You've already seen in our previous tutorial where the A's, B's and C's come from, so as always with me, let's get straight stuck in with an example and see how we apply this sine rule to solving a problem. If you're wondering when exactly to use the sine rule, we'll focus on that in a later tutorial. For now, we'll just concentrate on how to use it. We're starting then here with a non-right angle triangle, and I have three labelled points A, B and C. Remember that the angle at point A is called angle A with a capital, and so on. We already have a side A labelled, just check that this label is consistent. Side A should be opposite angle A, and we can see that it is, so no problem there, and let's move on. Opposite angle B, we have side B, and opposite angle C, we have side C. Just as with standard trig, I like to talk about active sides and active angles. Angle A is active as we're given it. Side A is active as we're being asked to find it. We're also given angle B, so that's active as well. And we know the length of side B, therefore side B is also active. We are not given any information about side C or angle C, so neither of these are active. If we look at our copy of the sine rule on the right, we can see that we're only interested in two parts of it. As we're not using the C over sine C part, I'm just going to cross it out, leaving me with A over sine A equals B over sine B. Right, we know lots of these parts already, so let's start and substitute in some values. A over sine A, it's side A on top, which we don't know, so we'll just leave as a lowercase a. And on the bottom we have sine of angle A, so sine 112. On the other side of our equation, side B is 2.8 centimetres over sine of angle B, so sine 19 on the bottom there. Okay, we want side A, and at the moment that is being divided by sine 112. So if we want to get that side A on its own, we need to multiply both sides by sine 112, which will give us A is equal to, deep breath, 2.8 over sine 19 multiplied by sine 112. As I always say, this is where having your own dedicated calculator is really helpful. You can enter everything on the right hand side in one go, exactly as it looks there if you've got a fraction button to work with. So enter that little lot, press equals, and you should get a messy answer that A is equal to 7.9741 and so on. We'll round that off to one decimal place, and that'll actually round to 8.0 centimetres. We've covered quite a lot there, so let's look at another question and follow this process again. Let's start by checking the labelled side C that we're looking for is opposite angle C. Yes, no problem there, so we can just leave that exactly as it is. Let's label side A opposite angle A and side B opposite angle B. This time, side A and angle A are active as we know both of them. We also know angle C and we're looking for side C, so these are active too. So on this problem, we're not interested in side or angle B, so let's wipe them out of our sine rule, leaving us with A over sine A equals C over sine C. Let's get substituting our values in then. A over sine A, so that's 3.9 over sine 68. Next we have C over sine C. Side C we don't know, so we'll leave just C on the top. Sine C on the bottom, so sine 74 there. We've got an equation now that we need to solve for c. To get c on its own, we need to cancel out that it's being divided by sine 74. So let's multiply both sides by sine 74. As on our previous example, we now have a complex calculation that if you've got a decent calculator, you can input all in one go and achieve an answer that rounded off gives 4.0 centimetres. Okay, on to one last question. This question would prompt panic from a lot of people, as A's, B's and C's have been replaced with X's, Y's and Z's. Now there are two ways to deal with this. Some people replace the letters they've been given with the more familiar A's, B's and C's. Nothing wrong with that, and I'll show you such a method in a different tutorial, but for this particular example I'm going to stick with the letters that I've been given. All we're going to do is replace the letters in the original sine rule with the letters in my question. So I'm going to replace all the A's with X's, all the B's with Y's, and all the C's with Z's, making sure that the case stays the same. Now that gives us a different looking sine rule that uses the right letters for my triangle. Okay, let's label our two sides up. Side Y opposite angle Y, and side Z opposite angle Z. Our active sides and angles this time are the X's and the Y's. So we're not going to need the Z part of our sine rule. We'll be using X over sine X equals Y over sine Y. Let's substitute our values in just as before. We need to multiply both sides by sine 68, which will give us the calculation that we need to input into our calculator, and if we do that correctly and tidy our answer up, we should get a length for x of 11.8 meters. Right, hopefully you're fairly confident now with finding sides using the sine rule. In the next tutorial, we'll start using the sine rule to find angles instead, which is really just a small extension to what we've done today. As always, check the website for lots more useful stuff and the ability to record your progress through these tutorials. Until next time, bye for now.